Oh, jeepers. Things are close, Parth. Danger close, Parth.
Hey everyone, Parth here, and in this video I want to talk to you about energy. It's a pretty central concept in the world of physics. For example, we talk about things like kinetic energy or potential energy or the law of conservation of energy. But what exactly is energy? Before we answer that question, it's worth me noting that we will be looking at the physics definition of the word energy. It's used in day-to-day life quite a lot to mean a few different things, and those meanings aren't wrong, they're just not the physics version, which is what we'll be looking at. Now, different scientists will define the term energy in a few different ways, and we'll see why that is in a
Because
second.
I have favorites.
But the first and foremost thing that I want to mention here is that energy is a very useful mathematical idea. It is a mathematical concept that helps us
Is favorites a
predict
word
how
like
the
energy?
universe around us
Does it
will
apply
behave.
X
Say, for
equals?
example, we're studying something like a car moving along
Math,
the road. We can
economics.
assign it a particular amount of energy based on the kinetic energy equation. This happens to be a carefully calculated
Half of that's
equation
going to be math,
that will allow
and
us
it's going to
to
be an
predict
MV.
what will
Whatever
happen to
M
the car
is,
and its
whatever V
surroundings
is,
if
A,
something
M
were to
would be
change.
a set
For
in
example,
the
if the
environment
car were to slow
by
down,
the
if its speed were to
velocity
decrease, then its
vector,
kinetic energy
the
would
squared
decrease as
factor
well.
at each of
This
those
exact
still
same
having the
amount of
system that
energy
makes it a
will
little
be
bit more real,
transferred to
a little bit
the
more
surroundings
real.
of the car in different forms.
No.
One example of this is the
You
energy
have to
transferred
generalize
to
it
the road
because
through the
this
tires
is a
of the
road.
car,
Yeah,
both
this
of which
is,
end up
well,
heating
the
up.
tub.
In other words, we
the-
could potentially measure the temperature change of the road. We can
Yeah,
see that
it's
the
just not
temperature
practical.
increases. The energy change that causes the road to heat up originally came from the energy change of
Well,
the
if
car.
you knew it
And
well
so the
enough, you
important
could tell
idea
the
is that we
service
can
of
assign
the tires,
different
and the
energy
energy
values
will
to
last that
different parts
long.
of the system
And
that we
it'll
have
be
to do
very
stuff
fine-tuned,
that
but
we
you
have
could
to
use
do.
IH
But this
instead.
whole idea about
IH.
assigning energy values
Right?
does not mean
And
that
so
we
I
can
could
assign
say, well, what's that mean?
absolutely
It's like,
any
well,
random energy value
tires
to anything
usually
in our
last about a
system.
year,
No,
so we
the energy
designed it to
values
be a
that we
year.
assign are based on some very
That
carefully
way,
calculated mathematics.
just
And the reason for that
arbitrarily
is that
you'll
everything
get
we see around
winter
us seems
tires
to behave in a very
every
particular
winter.
way. It seems to behave as
Right,
if
or
the
all
total
seasons.
energy
Like all
must
seasons
always
would
be
last
the
about a
same,
year
must
before the
remain
tread would
constant.
wear off
As a
on them
basic
from
example, let's
heavy
imagine a
road
superball
travels on
or a
highways or
moving along
bumps
a
or whatever
table,
comes up.
and it has
Those
an energy of
bumps are temperature
0.003
differentials on the
joules.
cosmic
But then
radiation background
something
given
changes.
vectors.
This ball
Remember,
collides with another ball placed
without
here.
some
At this
level of
point, lots of
comprehension
energy
in
transfers occur.
mathematics,
So, for
what
example,
happened, you're
the
going to
first
have a
ball
hard time.
loses kinetic energy.
But
because
you
it
drive
was
down the
moving
road
at a
every
particular
day,
speed before,
and you
and
figured
it's
it
now
out,
moving
you're like,
slower,
oh, one
so
of
its
those,
kinetic energy
exactly.
is lower than it
And you
was
could use
before.
that as
In a
kinetics
similar way,
in
the second ball
cyclical
actually
polarized
gains kinetic energy
photons.
as it speeds up.
Right?
And also,
This
there is
isn't
some
a
energy
ball,
that
but
goes
it's
into
it's
the
not a
clicking sound
square
that we
you
hear
driving
when
in the
balls
car.
collide. As well as this, there is some increase in temperature.
In order
of
to
both balls
describe
and
that,
table due to
you know, this
friction, and so
surface
on
of the
and so forth.
horizon
But if we
problem
account
here
for
is
all of the
zero.
energy
You know, what I'm going to say,
and we look
that's
at
the
the
Big
total
Bang.
energy of the system
You know, between
before
then and
anything
now,
happened,
just driving on the
and
road
after
to
something
now
happened,
driving down the
the
road
total
to now
energy
driving
seems to
down the
be
road,
exactly
or
the same. It's
zero
constant.
to when I
This
get to the
idea is known as the
destination.
law of conservation
Now, what
of
happened in
energy.
there
It seems like the
mathematically,
universe
without it
behaves in
actually
such a way
happening, the
that
Dark
total energy of the
Ages.
system is always constant.
Then you get the
And
first
crucially, this allows
stars,
us to
well,
make
you got
predictions about
the
how
first
certain
stars,
things in the
NF
universe, or
beginning,
the whole universe for
NF
that matter,
ending,
should behave
first
in different
stars,
scenarios.
vector
Now, many of
position,
you will be
Sophie star
familiar
here,
with this
Sophie
law
star
of
here.
conservation of energy. It's something that's
You know,
taught
this is
very
a Dyson
commonly
sphere
in
build,
high
but
school
like I said, we're
physics. And
moving
it seems to be a huge reason as to
astrologically.
why
We're on
the
a
idea
road
of
that travels
energy is
45. We
useful
would
in
know
the
we
first
need to hit
place.
certain
But
terms, see
physicists
certain
don't
signs
actually
on
know
this
what
road
energy
about how
is.
dangerous
Some
it
say that
is.
it's just a mathematical concept. Others say that it's a property that objects
Like
have.
I said, this
But
is
most
the
physicists will
universe.
agree
It's
that
not
the important thing about
this.
energy
In order to
is how
quantify
it
what this is, though,
changes.
you will
And
need to
specifically what I mean
use
by that is how it transfers
math.
from one place to
You want,
another and what impact
sigma
this
sum is
has
math,
on the
because
system
somebody's
we're
like
studying. The law of
environment,
conservation of
energy,
seems to hold
sigma
really well
sum.
in experiments that we've
And they
done
kind of
so
figured it
far.
out in one
as a
half.
result of
And in
this,
order
we
for
can
them to
use it
train
make
that, then they
predictions
started to
about how our
Bernoulli's
system should behave.
all these
If we can
differentials
measure
with a
something
car on
that
the
allows
road,
us to
with a
work
ball.
out how energy has
With
changed
you
in one
are
part
a
of the
ball.
system,
You
then we can predict how
are
another part of the system
a
should behave, for
ball.
example. Now, I just mentioned that sometimes physicists
Ball
treat
energy,
as a
hot
property
flaming
that things
morning star
have.
over
We
here.
often do this for simplicity,
Just
and
being
because it
not
makes
not
it treat
understanding it
successful.
always
For
to
example,
go.
if a car is moving, we say that it has kinetic energy.
Well,
rather
time
than just being a
dilation,
mathematical
wormholes,
quantity that we
relative
assigned to that
perspectives.
car. or
it's
if it's
gravity,
something
right?
like a ball
So gravity
placed
out
above the
there
surface
just
of the Earth,
being
we often say that it
IH
has
or
gravitational
GH
potential
or
energy by
GMH,
virtue of being in the
GSR,
gravitational field of the Earth. And
LSD.
in most scenarios, this idea that an object has energy
You
works
put a little bit on that marshmallow on the
But let me
table, and all of a
clarify what we
sudden,
mean by
that
that. It's
acid
easy
trip
to
turns
fall
into a
into some
math
common
calculus class on
misconceptions. For
averages
example,
of
it can be easy
students,
to imagine
long-term
energy
tracking
as
those
some
students.
stuff, like a fluid, for example.
This
And an object
drunkard
with lots
walk
of
problem
energy is
around
filled
here.
with this energy fluid stuff, whereas an object with less energy
Because I
isn't
wasn't
quite
actually
so
using
filled
a
with this
star.
stuff.
I was
And
using a
indeed,
guy
long
coming
time
out of the
ago,
bar,
scientists
drunkard
thought to
walk,
meet a type
on
of
an
energy
alcohol
transfer as a
solution.
fluid. It turns
Bar
out
at the
that
bar,
word
what's
fluid
law?
has a very
Math,
specific definition,
graphing
because we
averages,
have it
and
already. And
you
energy
learn a
actually
lot
behaves quite
of it
differently to this.
by
Therefore, I
what you learn.
personally
It's
think
high
it's more
probability
useful
in a
to
math
think of
class.
energy
You're going to learn to
as a
graph a
mathematical
bunch.
quantity that we can
You're gonna. It's
assign
not just
to whatever we
graphing.
happen
It's
to
the
be studying.
practice
And I find it
of
very interesting,
graphing,
by the
driving
way,
down
that
the
our
road.
system,
You know the
thing we
more
happen to be studying,
terms
can
in
be very, very small indeed, or can be as big as
macro,
our whole
micro.
universe.
It's
Now,
like
I quickly
galaxies
wanted
or
to mention
atoms.
that sometimes
And on that
different
scale, they
types of
behave the
energy,
same way.
different
Not
kinds of energy that we talked
directly,
about,
remember
can
0
seem like
to
a
1,
little bit of a mathematical
but
function. And for
mathematically
those of you that are
on
not familiar with this term,
spin
what we mean by
direction,
a fudge is
spin
basically
motion
a
direction.
sort of quick fix
I have to have it in the early
improvisation
position,
or just
mathematics.
something
The
that
high
can be done
probability of this
to make
class
maths
is to
make
do it
sense.
in
For example, I often
universal
get
speed
asked
limit,
about potential
and then the
energy,
result
whether
on
this
those
is
should
just a
correlate
mathematical
to
fudge.
in the
But
Hubble
with kinetic
45
energy, things are kind
of
of
the
obvious. An
cyclotron
object is moving,
is a car.
and that
Remember,
movement
G-force
is
worked this
associated
way,
with some amount
equally
of
like it
energy.
worked this way or
Object
this
speeds
way,
up, its kinetic
relatively
energy
speaking.
increases. If it
I
slows
don't know
down,
what
its
all
kinetic
stars
energy
out there in the
decreases.
universe
But
aren't
something like a
orientated
ball in the
on my
gravitational
CT
field has,
paradox.
like, stored
All
energy
brothers
that will
on here, we
allow
walk
something
on
to
Earth,
happen
but we
later,
have
like
different
fall into the ground,
orientations of
or a
math,
stretched spring has
economics,
stored energy
and we
within
have to
because
find a
the
way
spring will
to
eventually ping
zero
back.
that out,
Yeah, I can
cross
see why
all
feels
that
like a
out,
little
so
bit of a
we're
fudge.
eventually on
But
the same
firstly,
index.
this clearly
This is
illustrates the
quantum
problem
time,
with thinking
and it's
about
something
potential
specifically
energy
that I
as an
teach
amount of
by the
stored
standard.
energy in the
When he's in the
gravitational
class
field.
talking,
And secondly,
I'm
even
taking
if it feels
notes.
like a
And it
mathematical
makes its
fudge,
own problem
it's
at
important
times.
to note that potential energy works consistently across different systems. It tells us exactly
does.
what should happen when some amount of energy change
I hit an
occurs.
Euler's
For
number to his
example,
angle
a ball
because
with
I
a
saw a
mass of
bunny
1 kilogram
skate
placed
off.
about 10
And I want
meters
those
above
bunnies
the surface of
specifically.
the
I don't know
Earth,
why they did.
when released,
I want
should
'em.
accelerate down
It's
towards
gonna
the
make a
surface
problem
of the
for
Earth,
him.
and just before
It's
it
gonna
hits
make
the Earth's surface,
coin
it
for
should
me.
have this speed.
Z-press out of
And
that.
it does on a consistent basis.
Zcoin,
It doesn't matter if
blockchain,
it's a 1
mathematics,
kilogram ball or if it's
graphing,
something
indexes,
else,
prime,
as long
ones,
as
and
we're
zeros.
using the correct values for
Terminal
the mass
velocity of
the
that,
object, the height
9.8
above the
meters
surface
per
of the Earth,
second,
we're
derivative
maybe
L over
ignoring or
derivative
even
T,
accounting for air resistance.
derivative
And we
L
know
over
the strength of
derivative
the
T,
gravitational field, we can
mg
consistently
equal
calculate
mgh
the
equal
amount of
1/2
potential energy it
mv.
has and what impact
Well, they're
losing
broken
this
down.
potential energy
Remember,
will
what
have
is
on
what
the
is
object.
derivative L? They
Okay,
get
let
out
me
here
talk
and they'll
about
pump out a
another
bunch of
commonly
stuff,
used definition
and that
of energy.
arbitrarily
You
could
may
be a
have
black
heard that
hole out there,
energy
but that's the
is
one I'm
what
looking
is
at,
related
or a
to
star,
the
or a
ability
person,
to
a
do
bunny.
work. And work in this case is of course used in the physics sense.
And
It's
bunny's a
defined
black
as
hole.
force
You know
applied
it,
to
I
a
know.
particular object multiplied by the distance
It is
the
our
object
death,
moves.
that rabbit.
Or at least that's
That
a
wave
simplified
function
version. We
on
won't go
pursuit
into detail here.
algorithms and
Now, this is pretty
rabbit
reasonable.
population
But if we
calc,
try and
wolf
work out
population
what
calc, because
work
it's too
actually
general.
is,
It's like if
rather
you
than
just do
a
the
product of
output
force and
on
distance, then we might see a
Bernoulliing the
wordy
type of
definition
it,
of
it'll
work,
go
which
to
is that
limits where it
it's the
zeroes out
energy
over
transfer
years.
to
It
or
will.
from an object due
You
to
gotta
the
assume
application
that's
of
what that
force.
is, but
And
did
so
you
if our
calc
worded
all the
definitions define
SAMs?
energy
It's like
in
I
terms
tried
of
it on the
work and
rabbits.
work in terms of energy,
IH,
then this
looked
is a little
around,
bit
saw
of a
some
circular
rabbit
argument.
traps and some
And
little
if you don't
grenades
have
they
a
left
clear,
around on
intuitive
the
idea of
farm
what
for
one
me.
of these things
And I also
mean,
do
then
that
you're not
because
gonna
it's
care about the other
congruent
either. So
with wolf
basically,
tracks
energy is a really
or
useful
wolf turds.
mathematical concept. Beyond that, its exact
But I can't
definition
tell
is
you
quite
how many there
difficult to
might
pin
be
down
inside
with
there.
just
I
words
just see,
without doing a lot of technical work.
you
At
know,
the end
maybe
of the
they
day,
do
it
labs.
doesn't matter
You know,
what energy
if it's a
is.
little
What
grayer
matters is how it
here,
changes and
then
how it
this
allows us to
fresh
predict
one,
the behavior of
it's
our
going to
system.
correlate to,
The
well,
basis
that's
for this is the
potential
law of
inside
conservation
here.
of energy
That
and how energy
is
transfers occur. And with all
a
of that being
difference in
said, I'm
energy.
going to finish up here. Thank you so much for watching. If you enjoyed the the video, please do hit the thumbs up button and subscribe for more fun physics content. I've recently designed some merch based on a quantum mechanical dice design. I had a lot of fun creating it. If you'd like to check it out, please
I got a drill sergeant with a salt grenade. He's just standing out there on the island on the other side of the palm tree holding up his hammock, getting hard. Valentine Rabbit, that one with a black eye, scar over it, Conquest couldn't kill.